Hi, my name is Chi-Cheng Fu. I'm a robotics master student at Carnegie Mellon University. Now I will present our paper, Sequential Voting with Relational Box Fields for Active Object Detection. The active object is defined as the objects being manipulated by human hands. Our goal is to detect the bounding boxes of active objects along with their correspondence to human hands. This task is crucial towards understanding human-object interactions, especially in egocentric view, where hands are the only visible human parts. An accurate localization of the active object can be challenging due to natural occlusions caused by hands during interactions. On one hand, the hand occlusion makes it hard to detect active objects. On the other hand, prior research shows that the appearance of the hand actually contains important information about the location, shape, and the size of the active object. Previous methods achieve active object detection by first detecting the hands and objects independently using a standard object detector. Then interaction detector is learned to match the detected hands and objects. Those objects matched with human hands are classified as the active object. The drawback of this pipeline is that it ignores the hand-object interaction when locating the active object. Meanwhile, there's no specific design to handle the occlusion. Differently, our approach directly detects the active object in a sequential decision-making process dependent on hand. It fully exploits the feature of the hand, object, and their interdependency, and is designed to be robust to occlusions. First, we describe a voting process on relational box fields for object detection under occlusion. The relational box field is a mapping from every pixel to an object bounding box prediction. The pixel-wise predictions can be quite diverse because they are dependent on features from different locations in the input image. The voting function finds the consensus from pixel-wise predictions by selecting the bounding box with a majority vote. Similar to the half transform, our voting scheme is able to minimize the influence of outliers and generate stable predictions through the power of aggregation. Here are some visualization of the voting process. The red bounding box is the majority vote of the green pixel-wise predictions from the blue hand bounding box. As we can observe, the prediction after voting is closer to the actual active object than the outliers. As an overview, our method predicts a hand-to-object and object-to-object relational box fields using an encoder-decoder style neural network. Similar to the idea of boosting, our method applies multiple rounds of voting function to progressively obtain a more accurate active object bounding box from the detected hand box. Our method achieves state-of-the-art performance of hand-object interaction detection on 100 days of hand dataset. Further analysis of recall shows our method is more robust to severe occlusions. We also evaluate our method on the egocentric MECCANO dataset. First, we test the baseline and our method trained on 100 days of hand dataset, which demonstrate our method has better generalization ability across the datasets. The proposed method also gets better performance after fine-tuning on the MECCANO dataset. We also compare the qualitative results of hand-object interaction detection. The difference is highlighted using bold yellow arrows. As we can observe, our method is robust to the scenes where objects are overlapped or occluded by hands. In this slide, we visualize the intersection over union between the red final active object bounding box after voting and the pixel-wise predictions inside the blue hand bounding box. The red color indicates higher correlation, while the blue color indicates lower correlation. These figures show voting is able to adapt predictions from informative hand parts like fingers as opposed to the irrelevant parts like wrist and background. That's it. Please check out our website for the paper, code, and more visualizations. Thanks.